Taking a second derivative of an implicit equation like this can be a little tricky. Watch why. If you take the derivative of this, take the 3 up front, you get 6. Drop the power by 1, you get 6x squared. Minus, take the derivative of this, would be 2y. Don't forget y prime, or dy dx. Again, whenever you derive y, you need a y prime at the end. And then derivative of 3 is 0. So let's simplify this. I'm going to minus the 6x squared over. I'm going to divide by negative 2y. And when I simplify this, I get 3x squared over y. That's my first derivative. Now we take the second derivative. Okay, so we go over here. I'm going to, the derivative of y prime is y double prime. And this is a quotient rule. So with the quotient rule, derive the top, 6x, leave the bottom, minus, leave the top, take the derivative of the bottom. And then you square the bottom and put it right there. There is your second derivative. Now we simplify it. And especially because I have a y prime here. To simplify this, you'd be like, oh, what's y prime? It's right there. So what I'm going to do is I'm going to take this and replace y prime with it. A little tricky. When you take the second derivative, you have to take your first derivative and plug it in wherever you get a y prime. And taking the second derivative, you usually will get a y prime, and you have to go to the first to plug it back in. Very kind of little weird. So when I plug that in, now I got a little bit more simplification to do. When you multiply all this, okay, you get 9x to the fourth. Now, what did I do next? Well, if you can hopefully see here, is I multiply top and bottom here by y, so I can group this all together. So when I multiply top and bottom of this by y, once you get a y squared over y, and then when we group these, you get all of this on top over y, and you still got the y squared on the bottom. Alright, so make sure you get a common denominator for the top. Now this confuses people sometimes when I have a fraction over something. People forget, okay, where's everything going to go? But in this situation, when you have a fraction divided by this, when you divide, you are basically multiplying by the reciprocal. So what happens is you will hopefully notice that the y squared joins the y on the bottom, making it simply y to the third. Okay. And on the top, I always like to pull out greatest common factors if I can. It's just a good thing to be done. It's very useful at times. So when I pull out a greatest common factor of 3x, I'm left with this. I just like doing that. It's usually pretty good to do that. Remember, take the derivative where everything is at, get y prime, take the derivative of y prime, plug in y prime, simplify. A little bit more work, but you can do it.